Now in this lecture we'll answer two questions. In the first question we find out the area of this big rectangle AFQH, and in the second question we find out the area of this circle using two different methods. So we'll start with the first question. In the drawing we have rectangle EFQH. Inside this rectangle we have three circles. The radius of this circle, the small circle, is equal to 5 units in its length. The radius of this medium circle is equal to 6 units in its length. And the radius of this big circle is equal to 8 units in its length. Again, our test is to find out the area of this big rectangle EFQH. So first of all, we know that all the angles inside in this square, inside the rectangle, are right angles. So those four angles are all right angles. This angle equals to 90 degrees in its size. This is also a right angle. This is a right angle. Finally, this is also a right angle. We will implement rule 1 on our drawing. According to rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have tangent EF that is tangent to this circle at this point C. The radius SC is equals to 8. The radius SC is drawn to point C. That is the point of tendency of tangent EF with this big circle. And whenever your radius is drawn to the point of tendency, then tangent EF will be perpendicular to the radius CS. If EF is perpendicular to CS, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we have tangent HQ that is tangent to this circle at point B. So I'll not repeat on the same process. According to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, we have tangent EF that is 1 to point, tangent EF is tangent to this small circle at point A, and therefore this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. In the next step, we will define the point of tendency of tangent FQ with this big circle. This point is point L, and we will join points S and L together by a straight line. SL is of course the radius of this big circle, and it equals to 8 units in its length. According to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. We will define the point of tendency of tangent HQ with this big circle. This point is point T. We join points S and T together by a straight line. ST is of course the radius of this big circle, is equals to 8 units in its length. The radius ST is equals to 8. The radius ST is 1 to point T, that is the point of tendency of tangent HQ with this circle. Therefore, according to rule 1, this angle equals to 90 degrees. This angle also equals to 90 degrees. So in this quadrilateral CFLS, we have 1, 2, 3 right angles, and therefore this fourth missing angle must be equal to 90 degrees in its size, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, quadrilateral CFLS has 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be this rectangle if not a square. So in order to this quadrilateral CFLS as a rectangle because it has 4 right angles. But you also know that the opposite sides of a rectangle are equal to each other. So in rectangle CFLS, side SL must be equal to the opposite side CF. But SL is 8, therefore the opposite side CF must be also equal to 8 units in its length. The lower quadrilateral SLQT, we have 1, 2, 3 right angles, and therefore this fourth missing angle must be equal to 90 degrees in its size. So actually, this is angle CST. Angle CST equals to 90 degrees plus 90 degrees. That is 180 degrees. And we know that any angle that is equal to 180 degrees in its size, it is defined as a straight line. So CST is a straight line, and therefore CS is also a straight line. CS is a straight line because angle CST equals to 180 degrees in its size. So CS is a straight line. Therefore, this shape, actually, it is CT. Again, angle CST equals to 180 degrees in its size, and therefore CT is a straight line. Because any angle that is equal to 180 degrees in its size, it is defined as a straight line. Therefore CT is a straight line. CT is a straight line. Therefore, this shape CT edge EC, it is a quadrilateral. Why? Because it has 4 sides. 1, 2, 3, 4. It is a quadrilateral with 4 right angles. 1, 2, 3, 4. And you know that any quadrilateral that has 4 right angles must be this rectangle, not a square. So, relate to this big quadrilateral ECT edge as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in the big rectangle ECT edge, side TC, side CT must be equal to the opposite side E edge. But CT in total is 8 plus 8. Is 8 plus 8 because CST is a straight line. So CT equals to CS plus ST, that is 8 plus 8. That is 16. So CT is 16, therefore the opposite side E edge must be also equal to 16 units in its length. E edge equals to 16 units in its length. That is to say, we actually found out that the width of this rectangle EFQ edge is equal to 16 units. We will extend the radius BQ of this medium circle by a straight line until it touches side EF of this big rectangle. And we will define the point of tendency of tangent, and we will define this touching point of extended BQ with side EF of this rectangle, this point is point S. By doing this construction, we're going to do quadrilateral ESB edge. Inside this quadrilateral ESB edge, we have 1, 2, 3 rectangles. Therefore, this fourth missing angle must be also equal to 90 degrees in its size. So inside quadrilateral ESB edge, we have 4 angles, and therefore quadrilateral ESB edge is a rectangle. Okay, quadrilateral ESB edge is a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ESB edge, side E edge must be equal to the opposite side SB. But E edge is 16, therefore the opposite side SB must be also equal to 16 units in its length. So ES equals to 16 units in its length. SB, the opposite side SB, equals to 16 units in its length. SB equals to 16 units in its length, according to the rule that the opposite sides of a rectangle are equal to each other. ES equals to 16. In the next step, we'll join points P and Q together by straight line. Point P is the center of this small circle, point Q is the center of this medium circle. Here we can implement rule 10. You can click on rule 10. If two circles touch each other externally, then the straight line that connects their centers together passes through their touching points. In the drawing, we have two circles that touch each other at this point, point K. The center of this circle is here at point M. The center of this circle is here at point O. The straight line that connects their centers together is of course the straight line OM. And according to this rule, rule 10, the straight line OM must pass through their touching point, that is point K. Again, the straight line OM must pass through point K, that is their touching point. Or OKM is one straight line. OKM is one straight line according to this rule, rule 10. So we can actually implement rule 10 in our drawing, because in our drawing we have an external edge between those two circles, that is to say they touch each other externally at this point, point T. We define the touching point as point Z. According to rule 10, the straight line that connects their centers together, that is the straight line PQ, passes from point Z. Or PZQ is one straight line. Again, PZQ is one straight line according to rule 10. PZ is the radius of this circle, that is equals to 5 units in its length. QZ is the radius of this medium circle, that is equals to 6 units in its length. And because of the fact that PZQ is one straight line, it means that PQ must be equal to PZ plus ZQ. Again, PQ must be equal to PZ plus ZQ. So PQ equals to PZ, that is 5, plus ZQ, that is 6. So total PQ equals to 11 units in its length. In the next step, from point P, we will go perpendicular on SB again. From point P, that is the center of this small circle, we will go perpendicular on SB. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and SB, this point is point X. By doing this construction, we can do the right angle, triangle P, the right angle triangle PXQ. But here in the upper quadrangle ASXP we have 1, 2, 3 rectangles, and therefore this fourth missing angle must be also equal to 90 degrees in its size. So in the upper quadrangle ASXP we have 4 rectangles, and therefore quadrangle ASXP is a rectangle. So let it know. This is quadrangle ASXP, that is a rectangle. According to rule 5. But we know that the opposite sides of a rectangle are equal to each other. So in rectangle ASPX, side AP must be equal to the opposite side SX. But AP is 5, therefore the opposite side SX must be also equal to 5 units in its length. We have already found out that SB equals to 16 units in its length. So what is the length of this missing line segment? Line segment XQ. From the drawing it is very easy to see that XQ equals to SB minus SX minus QB. Repeat again, the missing line segment XQ equals to SB minus SX minus QB. So XQ equals to SB is 16 minus SX. SX is 5 minus QB. QB is 6. So in total XQ equals to 16 minus 5 is 11, and 11 minus 6 is 5. So XQ equals to 5 units in its length. This is the missing side SQ. This equals to 5 units in its length. In the next step, we will implement the Pythagoras theorem on this right green triangle, triangle PXQ. According to the Pythagoras theorem, in a right triangle, the square of the opposite equals to the sum of the squares of the perpendiculars. So I'll copy this right green triangle PXQ in the new pattern. We will implement the Pythagoras theorem on this right green triangle, triangle PXQ. Side PX is the missing side. Side XQ equals to 5 units in its length. And the hypotenuse PQ equals to 11 units in its length, according to rule 10. Here by PT is the abbreviation for Pythagoras theorem.